our solar system? Well, in our solar system, before it used to have 9 planets, but now it has 8. I'll tell you about that later. But first, I'll tell you what is middle. The sun is in the middle of the whole solar system. All planets revolve around it. People in ancient Greek before, they thought that the sun was just rotating around the earth. Because the sun just moves around the earth. But what they didn't know, that the earth is spinning around, making it there's daytime and nighttime. So our first planet is the closest one, which is Mercury. Although it's close to the sun, it's not the hottest. It's mostly dry, no life, no water, nothing, just a sad planet being really hot and just a couple 100,000 kilometers away from the sun. It's blazing hot at around 867 degrees. But what's interesting, that on the side, the night side where there's no sun, it is very cold, blowing down to minus 10 degrees or even colder. The sun is probably very hot to heat up any planet, depending on how close they are to the sun. But our second planet, which is the hottest in our solar system, doesn't even care about how far it is. It stocks up on heat because of the planet's yellow carbon dioxide heat the atmosphere. The carbon dioxide acts like it's a greenhouse gas. If you don't know about the greenhouse gas is like this. This is acting there are 3 types of greenhouse gases: methane, carbon dioxide, and another type of gas that I forgot. These 3 types of gases act like a greenhouse. And if you also don't know about greenhouse, so it's simple. It's a place where plants, it's a place where there's like cased with special casing glassing, I guess. And heat can go into it very easily, but that it will never escape. Building up the heat inside, the plants will feel warmer, so they be kept warm and even in the winter. And these gases, or greenhouse gases, act the same like greenhouse gases. Yes. The heat from the sun goes into the atmosphere very easily, but can't get out because they trap it, so they kept the warmth. But it's not really efficient. The greenhouse gas is way more efficient. The greenhouse is way more efficient at keeping heat than the greenhouse gases. They somehow may tend to leak out a bit of heat, but still do a good job at containing it. The second planet is also which is the hottest planet, reaches about 967 degrees. Since the atmosphere is mostly covering around the planet, it also builds up heat everywhere. And even if the sun's and the atmosphere is covering up the sun's light, so it may be dark down there and be hot at all times. th- and there are mostly probably some active volcanoes due to molten heating from the rocks. These types of volcanoes can erupt and increase the planet's temperature. And I guess for my assumption, the Venus is slowly being hollow and filling with liquid magma, and the core is hot. Our third planet, the third planet is in fact our home. Our planet, Earth. It's in the Goldilocks zone. It's in the Goldilocks zone. This Goldilocks zone, which means it is far enough to not be too hot, and it's close enough to the sun to be not too cold. So, any planet in the Goldilocks zone might have a chance to sustain living things. And before, the Earth was in the Goldilocks zone, but it cannot sustain any life forms because it was built up by rocks, asteroids colliding each other. And our planet is the closest planet to the sun to have a moon. Satellite. The and why is the moon revolving around the Earth, you ask? Well, it's simple. When the Earth is getting collided and heating up with many asteroids colliding each other to build up the mass for the Earth that we live on. One of the big planets, it somehow managed to hit the Earth. It was smaller than the Earth back then, but it was big enough to launch out some debris, and those debris collided each other to form our moon. And since it's easily to sustain life, it can keep up water. And where did the Earth get all of its water? Well, it's simple. Water comes from asteroids. Some asteroids contain water, and when they collide down, they evaporate. And there's so much water that evaporates, so they rain a lot. They rain like a very long time. And then Earth just became an ocean planet. But there were volcanoes erupting to form lands, but they don't have anything to move on land or even food for them, so it's not worth it to go up. And before there was even a life form, there was only one type of life form. Actually, many types of life forms. Planktons, bacteria, all of that. And some of them became organic. Some of the tree gens are from the bacteria because mostly they can do photosynthesis. And before they can even do photosynthesis, they usually chill at the bottom of the ocean, eating a special type of substance or compound that was from the asteroids that was colliding into Earth. And then one of the types of the bacteria somehow started a mass killing spree. Instead of attacking each other, it takes food, energy, and all of things that make God releasing oxygen, just like a plant. And a lot of the new life and different types of species and of that one that has a problem. Oxygen was deadly to them. So when the bacteria that make oxygen start mass producing them, it has accidentally caused a mass killing spree, because all of those types that were considered as oxygen was toxic to them killed a lot of them, causing a mass extinction. And the oxygen producing bacteria alive and somehow managed to build into every single form, like fishes and all of that. When fishes stop walking and evolve into many types of species, they have become dinosaurs. And the dinosaurs were chilling, having their normal life long, eating, hunting, running, hiding, and eating all of that. There's one, and then another asteroid is like, hey, can I join? And then accidentally killed everything on life on Earth. Nah, except for some species who was lucky enough to manage to survive. And before the asteroids, there were cockroaches, like cockroaches right now. They have somehow managed to survive the asteroid hit and survived many nuclear bombs. But it survives the radiation, not the fireball or the blast zone of the nuke.